Alright, so if you're not familiar with shaders, let me first ask you this. Have you used shaders in any of your Flutter applications in past? If your answer is a big no, then let me tell you, my friend, that you have. In Flutter, every widget and every application that you built, even the basic counter application, is behind the scene using shaders. Shaders are responsible to render pixels onto your screen. So behind the scenes, Impeller, the rendering engine in Flutter, uses shaders to build all kinds of widgets. For example, as you can see this colored box, that colored box is also rendered with the help of shaders, and this is how colored box is actually converted into a shaders, and this is the code I took from the Impeller rendering engine from their GitHub repo. If you're getting confused what is this fragment shader file, so it is basically written in GLSL, that is OpenGL Shading Language, and it is responsible to create these shader files. Alright, let that sink in, because in this video we're going to build our own custom fragment shaders to build some really cool effects, that is fire and rain in Flutter. We don't have any fire widget or rain widget in Flutter, but we are going to build our own custom fragment shaders and create this rain effect inside Flutter. And the interesting part is that the shaders are going to be interactive. So they are going to interact with the other widgets that we have inside the application. So let's open up the IDE and see how we can build this. Alright, so first of all, let's clear what are shaders exactly. As you can see, shaders are the small programs that run on GPU. So we write our code. For example, we write code in Dart, we write code in other programming languages as well. And all of that code that we are writing runs directly in the CPU. But sometimes there are a few graphic intensive tasks where we require the help of GPU. So to interact with GPU, to tell the GPU directly what data needs to be shared and where vertices we need to render. If we have a graphic intensive task, then to communicate with the GPU itself, we need a programming language to actually interact with the GPU like we do in the CPU side. So on the CPU side, we have Dart, we have multiple languages that can interact. But to interact with GPU, we have the language called as OpenGL, which is kind of similar to C language, right? So basically what shaders are these small programs that run directly on the GPU. And it is basically responsible for manipulating these visual elements. It can be either 2D or 3D scene, right? So we understood what are shaders, but let's understand in a traditional graphic pipeline, like in a traditional way, how shaders are being used. So initially there are multiple types of shaders, but first of all, in a traditional pipeline, we have vertex shader, and vertex shader is responsible to calculate and to see where and all we need to render the vertices of a triangle. So for example, if we need to render a triangle on the screen, then what vertex shader will do is it actually determines the actual vertices on the screen. So we have the screen space and we have the vertices. So the vertex shader determines, and we as a developer tell where we need to render that particular triangle using OpenGL. Now, once we have the vertices defined, what we need to do is we need to rasterize it. Rasterization meaning that we need to add pixels and we need to actually render pixels in that particular area. So to do that, we have fragment shaders. Now the fragment shaders or pixel shaders are actually responsible to render pixel onto the screen. So what fragment shaders are responsible is fill up each pixel in that specific area. So that is how, like, a very high level of a graphic pipeline where it starts with the vertex shader and it somewhat ends with the fragment shader. Now in case of Flutter, what we have is Flutter uses just the fragment shaders. It does not have support for vertex shader. So behind the scene, the graphic engine behind Flutter, Impeller or Skia, actually uses this fragment shaders a lot. So whenever we render a container, any widget that you can think of in Flutter, we are actually converting that widget into a fragment shader, and these fragment shaders are usually written in .frag files. So we have these .frag files written in the open source GitHub repos as well in Flutter, so you guys can check it out too. And yeah, so that is the whole ideology. Now if you're thinking that how does Flutter not use the vertex shader, so if we have this traditional pipeline where we need the vertex shader first to actually move on to the fragment shader, what Flutter does is, in its architecture, is the vertex shader is actually responsible to determine the vertices of that particular component where we need to draw it onto the space, right? What Flutter does is, in the Flutter itself, we calculate the vertices in the CPU itself, right? So Flutter in a way uses CPU itself to calculate the vertices and the points where we need to render any component or any element, and then it passes on to the fragment shader all of those data. So all of the vertices and wherever I need to render, I can just pass on the details to the fragment shader, and the fragment shader basically renders everything behind the scenes in Flutter. So that is what is happening, because in Flutter we only have one shader support, that is fragment shaders, and that we are going to look further in the video as well. Alright, so we have few of these basics cleared up. Now let's move on to our Android Studio and let's see how everything works. Alright, so as you can see, our project is running, and in the right side you can see that this is the application that we are going to build in this video, and that is the rain animation over here, and we are utilizing this shader. So this rain particles that you are seeing that are being rendered using shaders that we'll talk about. Then we have the splash effect. So as you can see that this whole thing is built in Flutter itself, and this part is the SVG that we are using. So I'll talk about how we can build shaders in a way so that it can actually interact with the Flutter widgets itself, right? We'll be using context for that, but yep, as you can see, as soon as it interacts with the widget, it shows the splash animation. Cool. So let's go ahead and see the folder structure a bit. And here you can see that we have fire and rain folders. Let's first talk about the rain animation. So here inside the main.dart, I am showing the rain app. And here inside the rain app, it looks pretty much like a normal Flutter app, right? So it is a stateful widget, and I can see that we have this material app, scaffold, and it is a stack, and we have 3 widgets in total. So you can see that on the first layer that we show is the SVG, right? So we show the person SVG right over here, and on the second layer, what we show is we show this umbrella clipper. What that means is, if I just change the transparent to red just to showcase, as you can see that this is the red portion, the second layer behind the SVG. And that is the widget which interacts with our shader. How it interacts, basically we are using this global key, and using this global key we actually calculate the rectangular box around this widget, and accordingly we specify if the rain particle is inside that bounds, then we basically show our splash effect, right? So that is how, using person key, if I comment this widget out, what's going to happen is, as you can see, that the rain is going through the umbrella because we don't have that widget in between, and our logic is written based on that, right? So how I built this is, it's basically a clip avatar, so sorry, a circle avatar. So it is a circle, and I wrapped it up with a clip oval. so that we can actually like mask it. So if I open up this umbrella clipper, you can see that we are simply clipping the actual circle avatar based on the width and height. So I specified height as 50. That is why it is just clipped over here, right? So that's pretty much it and how it is interacting. The person key you can see is initialized over here inside our stateful widget, and this person key is getting passed to our the behind layer, that is the game widget, and we are passing the person key inside. So this game widget actually comes from the Flame package itself. Let's talk about what are the packages that we are using. So inside the PubSpec YAML, you can see that we are only using two packages, that is Flame and Flutter SVG. Both I have just talked about. So Flame we'll be using to actually, so Flame is a game engine that is written in Flutter, and we'll utilize it for some particle effects that you are seeing over here. So this rain particles, and even we are adding these game objects into our scene. So Flame makes it super easy for us. And then we have this Flutter SVG, which actually helps us to render this SVG. And this SVG is over here inside the assets folder, right over here. Yep. I am adding the assets in the PubSpec YAML, as well as you can see that we have to assign our shaders as well, that we'll talk about. But initially we need to initialize our shaders in PubSpec YAML. So I have this shaders folder where both the fire and rain.frag file is initialized, as we talked about in the intro as well, that we need to have this fragment shader file with .frag extension. We'll talk about this code as well, but I have initialized those shader in the PubSpec YAML as well, and you need to do that in the same syntax, right? So let's go back to our app, and here we have our game widget, which actually is inside the Flame library itself, and it requires a game. So we are passing our rain game here, which is nothing but this game.dart file. And yep, let's talk about it. So right over here, first of all, we are passing our global key. Let me just rename that to person key. Yep, and let's rename this to person rectangle. Perfect. So what we are doing is, inside this Flame game, we have two methods that we need to override. First of all, we have onload, and then we have update. You can think of onload as init state of a stateless or stateful widget in Flutter. So basically all of the initialization that we have to do in our code, we will do in onload. So here we have our timer that we are utilizing, right? So this timer is basically coming from the Flame itself as well, Flame timer.dart. And we are utilizing this timer to render every 0.08 second. We are going to add raindrops, right? So we are going to add this raindrop component, which is inside our components folder that we'll talk about. So this raindrops that you are seeing, every 0.08 second, we are adding more game objects. So in our case, the game object is nothing but raindrop. This add method is coming from the Flame library itself, so we don't have to worry about that. And our raindrop component takes a position, which is a vector 2. So we need to define our X and Y coordinate. Now, obviously our Y axis will be 0 since we are initializing our raindrop from the top of our screen. That is why we set it as 0. And for the X axis, we are utilizing the random class from the Dart math library. And using that, we are simply getting a random next double, right? So based on the total size of the frame, we are getting a random X value, X axis value, and passing the whole vector to the raindrop. So you can see that these raindrops that are keep popping up, they are actually having a random X axis value, right? And in the onload itself, we start our timer as well. So that is about the onload. Let's talk about update now. So in the update, the code is pretty much simple. What we are doing here is we are first of all taking the context out. So we have this person key, basically this widget, this circle avatar widget, where we wrapped around where we passed our person key. So we are utilizing that and we are getting the context, and this code might look familiar. So what we are doing is we are getting the render box with this context.find render object, and based on the box we are actually calculating the top left value and the box size. So with that we calculate the rect, that is the entire box, and with that what we do is we simply have a for loop here where we are getting the children. So this children represents all of the game objects that are right now in our frame. So every frame we are checking children that is of type raindrop. So all of the raindrops, then for each drop we are getting the global position of that, and we are checking if that drop is inside the rectangle. So if it is inside the bounds of our person box, then we specify that, okay, we need to add a splash effect and remove the drop, right? So that is what we are doing, is as soon as it interacts with this box, we show our splash effect and we remove the drop from here as well. So we remove the drop game component. And that's pretty much it. So let's go over to our splash effect and let's see how it is working. So we are utilizing the flame particles library to actually show this particle effect, the splash effect, as soon as the raindrop and our bounce box interact. So here we are simply passing in the position where they are interacting. So you can see that as soon as we detect a collision, then what we do is we simply pass on that particular drop dot position as well to our splash widget, so that at that same widget where it collided, we show our splash effect as well. Now it takes few parameters, like we can pass count. If I make it 100, you can see that each effect that we have over here, after interacting with our widget, it makes 100 particles. So inside our splash effect we have 100 count of particles. So for now let's keep it as 8, so that right now we have only 8 particles that are generating. The lifetime represent how much time the particles will stay alive. So if example I can change it to 5, then now you can see that the particle remains inside the frame for much longer time, right? Rather than if I set it to 0.8. Perfect. Another thing here, so we are actually calculating the speed and the angle that the particles needs to react, right? So what we are doing is we are basically getting a random speed for each particle effect, and based on that we are simply moving the particles in the upward direction. That is why we have -1 over here. If I remove the -1, then you will see that these particles are interacting below it. So what we want in our case is we need the particles to move upwards. That is why we need to change the angle over here, and yeah, it makes this splash effect. And after this angle over here, we are specifying the upward angle as 60 to 120 degrees. So between that, these particles are going to spread out with this particular speed. So we are simply calculating the velocity using this formula, and we are passing our velocity to this accelerated particle which is provided by Flame itself. So we pass in the acceleration and the speed, as well as our circle particle with the random radius, and that's pretty much it. And we pass our paint and lifetime as well. So that is how we are rendering this splash effect over here. Now let's move on to our raindrop and see how we are utilizing the shaders. As you can see, we are loading in here, but let's go on the top. And over here, we are specifying the drop size first of all. So we specify the size of the drop and we specify the gravity. Next, we have the velocity. So the velocity you can see is the x-axis is minus 150 because we want our raindrops to move a little bit left as well, because you can see the wind is flowing towards the left side. So that is why I added 150. If I just make it 0, what's going to happen is now all of the raindrops are directly dropping from vertical 90 degrees. So we don't have this wind effect. But if we add some minus 150 probably, then you can see that now the raindrops are moving towards the left side, right? Another thing that we have here is we are specifying our shader over here. So we have our prog and shader. So we are specifying first of all our fragment program and loading our shader. So here you can see that we have three override methods, that is on load, update and render. So we have this is loaded boolean that we can use to actually see if our frames and if our game is loaded or not, meaning if we have initialized our timer, right? So if it is not loaded, then we are not rendering anything. This is where we actually render our shader. So as you can see that we are utilizing our shader by passing our shader inside the paint, and then we are simply drawing it within the specified bounds, the size that we are passing in, right? But let's go over here and in the update, because that is where each frame, by each frame we are updating in the update, and the onload is where we are initializing our shader and the fragment, right? So first of all we initialize, and then here in the update we are basically specifying the velocity and the position, right? So whatever position it was in the last frame, we are incrementing the velocity and the position and the time variables over here, and we are simply checking here like if it is loaded or not. Otherwise we basically set the floats in the shader. So what we need to do is, for example, right now we have this rain shader, we are specifying few floats. So we need to pass on the data from our Flutter to our fragment shader. That is what we talked about in the intro as well, that Flutter does not provide a vertex shader, because all of the coordinates and all of the vertices that we need to render, we actually pass all of that information directly from Flutter. So all of that logic is being ran on the CPU itself, and the rendering part is being done by the GPU. So you can see all of this rendering is actually happening by the graphics card, and that is happening by the GPU. So we are simply setting our float, and inside our rain you can see that we have these floats specified in the uniform vector resolution. So this resolution we are passing, that is the size of our frame over here. So we are passing in the X and Y of the resolution, we are passing in the time, and we are passing the speed, the velocity over here. So that is what is required, that all we are passing from Flutter. And this is basically the shader for this rain effect. Check out the code as well in the description box, so you can check this shader out as well. And yep, that is pretty much it, how we are rendering this particular animation. Let me just go back, and over here let's make it transparent again. So that is how the splash effect and the raindrops are actually interacting with the Flutter widget. Similarly, with the same concept, so this idea, if you're thinking like in a normal Flutter app, where can we use this kind of rain effect? Then one thought that came to my mind was that we can build probably a weather application where we can show the raindrops in the background, and it can actually like collide with the widget itself, like a container we can have, and the droplets are falling in, and adding in the splash effect. So we can add that kind of animation in a weather application. Another thing is, so we have a fire effect similarly. Let me just, the whole idea of this video is to show how Flutter actually can use these shaders, and we can build all of these complex animations. So you can see that this kind of shader, it wouldn't be possible for us to build with just custom painter or canvas even, because we would need to use these type of shader using the fragment shaders that we are using. So the idea is pretty much the same that we just talked about in the arena animation itself. We are interacting with our widget. So you can see that this is actually a widget over here, and our fragment shader is interacting with it. So code base looks pretty much the same. We have this fire app, we have our game widget, we are passing in our button key, and this is the button key, the global key, which is assigned to this elevated button. And over here inside our fire game, similarly we have our timer initialized, we have our context, and for each collision we are checking if the fire is inside the box bounds. If it is, then we just show the sparkle animation. So you can see that there is a sparkle effect over here, and we remove our fireball from here. In the components, we have the sparkle. Similarly, we are calculating the particle like we did in the raindrop. And here in the fireball, very similar code that we are calling our fire.fragment file. And similarly, we are passing in our shader. So here in the fire.fragment, it is a little bit more complex because we have to show the inner part of the fire and this kind of animation that is rendering in the fireball. Okay, so that's a wrap. I hope you learned something new in this video. Subscribe to my channel if you want to learn more about AI, agentic application, Flutter, and building mobile applications. Check out this video where I built an AI agent and embedded that within Siri actions. Or check out this video because YouTube thinks that you'll probably like it, and I think that too. I'm Yash Markan. See you next time.